All right, this is Honors Algebra 2 Pre-Calculus. We're doing 5.2 in Algebra 2, which is Intro to Solving Quadratic Equations. So we're going to start with the most basic quadratic equations, ones that have no linear term, meaning b is equal to 0. So what I mean by that is if you think about what we saw, quadratics are ax squared plus bx plus c, right, equals whatever, right? So equals a number. But what we're saying when I say b equals 0 is that this term is non-existent. So I have ax squared plus cx and that's, or plus c and that's it, no bx term. So now they use different letters here. Here they're using x squared equals a, which is super confusing and not helpful because obviously you're used to the form that we talked about in the last video. So it would be helpful if they picked a letter that wasn't a, but they didn't, so here we are. So a in this situation is not the coefficient of x squared, it's just a number, right? So if x squared equals a, and a is greater than or equal to 0, then x is called the square root of a. So if a is greater than 0, the number a has two square roots, the square root of a and the negative square root of a. The positive square root of a, which looks like this, which looks like root a, is called the principal square root of a. And if a equals 0, then the square root of 0 is 0, which is why there are not two of them. So when you solve a quadratic equation in the form x squared equals a, you can basically use this rule below, which is x squared equals a gives you x equals root a or x equals negative root a. Another way to write that is this plus or minus symbol times the square root of a. Now you might say, cool, Hogan, but why the plus or minus? Okay, well, so the logical reason for that is if I tell you, if I say 5 squared, you tell me, hey, cool, that's a 25, right? If I say negative 5 quantity squared, you say, cool, that's a 25, right? So if I tell you that x squared equals 25, well, there are two possible values that when I square them can get 25, right? When I take the square root of root 25, that naturally gives me only the positive 5 answer, right? So in order to account for that, I say, oh, that could be a positive or a negative, right? Even roots always have a positive output. So I get plus or minus 5 as my possible answers. And you can see up here that 5 squared gives me a 25 and negative 5 quantity squared also gives me a 25. So that's the reason that we need that plus or minus. Now, when we talk about properties of roots, right, if you have multiplication within a root, you can split it apart as two separate roots. So when we talk about this first property, right, let's say I give you the square root of, let's do 40, okay? I could write this as the square root of 4, which is a perfect square, times the square root of 10, which is not a perfect square, and that would give me 2 root 10. This is a simplified version. Okay. That 2 root 10 is said to be the simplified form of the square root of 40, right? So what we've done here is we've pulled out anything that's a perfect square, and we've left anything that's not a perfect square, and we end up with this 2 root 10, right? So division functions the same basic way. If we look at this second rule, right? So if we look here, right? If I asked you to do the square root of, let's say, 100 over 9, that's the same as the square root of 100 over the square root of 9, which would be a 10 over a 3, right? Now, an interesting thing to note about this plus or minus thing, because some of you are probably thinking, but Hogan, why isn't a plus or minus 10/3? Well, the reason it's not plus or minus is because I only have to write plus or minus if I write the square root. So here's what I mean by that. If I ask you, what is the square root of 36? Your answer, and the only answer, is 6, right? But if I say x squared equals 36, well, x could be one of two things now, right? X could either be root 36, which would give me a 6, or x could be a negative root 36, which would be a negative 6. So they're different questions. So the output of an even root, right? So an output of an even root is always positive, right? If I just ask you for the square root of 25, the answer is 5 and that's it. If I ask you for the square root of 100, the answer is 10 and that's it. But if I tell you that x squared is 25, then there are two possible values of x. X is plus or minus 5, okay? And that's the difference there. Okay, moving on. So in example 1, we're going to solve 4x squared plus 13 equals 253. We're going to give the exact solutions. Then we're going to type in our calculator and give approximate solutions. I'm going to show you a couple ways to do that in your calculator. We're going to approximate to the thousandth, not the hundredth, because it's always the thousandths place for the AP Calc exam, and we should get used to it. So let's walk through the exact answers first, okay? So when I'm asked to give the exact answers, I'm going to go ahead and use SADMEP, right? The same thing that we did when we solved linear equations, right? So I have 4x squared plus 13 equals 253. I see that there is subtraction and addition that I can do. I can subtract that 13. So I'm going to get 4x squared equals 240. Now there's division and multiplication, so I'm going to divide both sides by 4, and I'm going to get that x squared is a 60, right? And now I have an exponent to deal with, so I'm going to take a square root. But if I'm the one who writes the square root, I need to write a plus or minus. And the square root of 60 does simplify, because 60, right? 60 is a 4 times a 15, and 4 is a perfect square. So I'm going to get that this is plus or minus 2 root 15, and that's my exact answer, okay? Now there are two ways to get my approximate answers here. I can either type those into my calculator, and I can say x is approximately, and then I can type into my calculator what 2 root 15 is, and that's fine. And I don't have to type it twice because it's the same number in this case, so I just need to write it once, right? So this is the number I get when I type it in my calculator. Drag this guy over here, right? So I get that when I type it in my calculator, and that's fine. I would round or truncate to the thousandths place, so I either get 7.745, right? That's if I truncate. It moved, sorry. Hang on, it moved from where I put the line, okay? Or I get 7.746 if I round, right? And either of those are fine, and I would get the same answer down here, but with a negative, right? 7.745 or 6. Now, you shouldn't write the 5 or 6. You should either pick 5 or 6, but I write both so that I, as the teacher, know that either answer would be right. But if you wrote 7.744, I would mark you wrong, because that's not right. Okay, the other way to do this in your calculator is if you go to your calculator, you can put both of these into the calculator. You could put, now I'll walk through why I think this is not an awesome plan, but you can put this in as y1 and this in as your y2, and you could second calc intersect, right? So you could make your y1 4x squared plus 13, you could make your y2 253, and you could do second calc intersect. The only thing that's not awesome about that is that you're going to need to make sure you can see y values up to 253, and normally we're in a Zoom standard. Now we're not in Zoom standard right now because the last problem we did in the last video had numbers up in the thousands. But you would need to make sure that you have the ability when you go to your window, you'd probably still do something like the typical x negative 10 to 10, right? But for the y's, you need to make sure you can see up to at least 253. So honestly, you mostly only care about 253 anyway, so you could start way down here, or you could really say, hey, I don't even care. I'm just going to go ahead and start at 240 and go to 260 because I don't care about anything other than that, and that would be fine, right? And if you graph, you'll find your 2 points of intersection. You could also make your window, if you wanted, you could make your window go something like 0 to 300, and you could go by something like, I don't know, 50s instead. That would also work. Either way, you're going to see those points of intersection. So then you do second calc intersect, which is 5, right? And then you're going to follow those instructions. Basically, the instructions say go on one curve until you get the intersection. Now, you might notice that this is going to take a while if I scroll. Fun fact, if you use up and down arrows, you jump which curve you're on. So jump to the curve that's faster, because that straight line distance is going to be a lot faster than the curve. Oh, my bad. Hang on. Second, okay, wait. Graph, second calc, intersect. My bad, sorry. The stupid pen went in the wrong direction and it caused a problem. All right, there we go. Enter, enter, enter. There's my answer, and then I would find the other answer the same way. That's fine. You can either do it on the calculator or by hand, as long as you know that if you have to find the exact answers, you're really going to have to do it by hand, right? If you're asked to find the exact answers, right? This is exact. These guys are my approximate, right? So these are exact. This is approximate, right? So let's go ahead and do a P1. Same idea. So pause me if you don't want me to do it. So 5x squared minus 19 equals 231. I'm going to do subtraction and addition first. So I'm going to get 5x squared equals 250. I'm going to do division and multiplication to get x squared equals 50. When I deal with the exponent, I'm going to get that x is plus or minus the square root of 50, but 50 is really a 25 times a 2, right? I want to pull out the biggest perfect square I can, so this is going to be plus or minus a 5 root 2, so that's my exact answer. Now, you could put this in your calculator to find, so if you wanted, you could put this in and do this, and you could find these 2 points of intersection. There's nothing wrong with that. I would argue that this one's easy enough by hand that it makes a lot more sense to type into your calculator what 5 root 2 is. So if I quit out of this and do 5 root 2, I'm going to get 7.071. Now, in this case, I'm going to go ahead and screenshot that and grab it over and bring it over. So I'm going to get 7.071 plus or minus, and it doesn't matter if I round or truncate because in either case it's going to be a 1. All right, so for example 2, we're going to solve, again, let's go ahead and solve by hand. This should turn out pretty nice. So when we go to solve this, right, let's start with subtraction and addition. So we're going to use SADMAP. So one of the things we're going to see when we get to 5.3 is we're going to learn how to solve by factoring, right? So when we get to 5.3 and we talk about factoring, factoring is usually going to be useful when you have mixed powers of the variable. So what I mean by that is that we would want to solve by factoring if I had something like x squared minus 4x plus 3, right? So see how I have a squared and a linear term, right? But when possible, if I don't have mixed powers of a variable, I want to go ahead and solve by SADMAP. So I want to look for subtraction and addition first. Now in this case there isn't any, but there is division and multiplication. I can divide both sides by 9. It does not get much nicer than 121 divided by 9, so as much as you're going to hate that, you kind of got to leave it that way. But it is worth noting that 129 divided by 9 are both perfect squares, right? So then I'd look at my exponent and I say, cool, I need to get rid of that squared. So I'm going to write a plus or minus the square root of 121 over 9, which for the record is plus or minus an 11 over 3, right? Because 121 is a perfect square and so is 9. So I now have two situations. I have that x minus 2 could be 11 thirds, and I have that x minus 2 could be a negative 11 thirds. So I'm going to go ahead and do that last bit of work, that parenthesis, and add the 2 over. So this is going to be an x equals 11 thirds plus 2, which would be 6 thirds. So I'm going to get x is 17 thirds. Or, in this case, I add the 2 over, and this will be a negative 11 thirds plus 6 thirds, which is going to give me a negative 5 thirds. Now, a point of clarification, if the root had not simplified, another way to write this is to just add the 2 over and write plus or minus 11 thirds, right? Add the 2 over, keep the plus or minus in front of the 11 thirds. And that's not wrong, but it would be frowned upon in this case, right? So you would use if the root was still a root. So what I mean by that is, let's just say, for example, my answer was something like x equals 2 plus or minus root 5. Well, then I don't have to write it as two separate answers. I could just leave it as 2 plus or minus root 5, right? That's not the example in this particular problem. Like, that's not the answer in this problem, but there'd be nothing I could do. Here, I'm able to combine the fractions. There is no root anymore, so I should do so. All right, let's look at a P2. Go ahead and try this. You can do it without me if you want. There is no subtraction and addition. There is division and multiplication. I'm going to divide both sides by 4, and I'm going to get x plus 2 quantity squared equals 49 over 4, right? When I go to get rid of my exponent, I'm going to take the square root of both sides, and I'm going to get that x plus 2 is plus or minus the square root of 49 over 4, which is plus or minus a 7 halves. So technically, my answer could be written as negative 2 plus or minus 7 halves, but because those answers can be combined, I should combine them. So negative 2 plus 7 halves is the same as a negative 4 halves plus 7 halves, or a 3 halves. Negative 2 minus 7 halves would be a negative 4 halves minus 7 halves, which would be a negative 11 halves. So those are my two answers. So x is either 3 halves or x is negative 11 halves. All right, let's do an E3 and a P3, and that'll be the end for this video. A rescue helicopter is hovering 68 feet above a boat in distress and drops a life raft. The height in feet of the raft above the water can be modeled by h of t equals negative 16 t squared plus 68, where t is the time in seconds after it is dropped. how many seconds after the raft is dropped will it hit the water? So the first thing we have to recognize is that the colloquial phrase hit the water or hit the ground means that the height is 0. So they're asking us, when is 0 equal to negative 16 t squared plus 68? So I'm just going to go ahead and solve using SADMEP. So I start with subtraction and addition. I go ahead and subtract the 68, right? Negative 68 equals negative 16 t squared. Now I do my division and multiplication and divide by negative 16. So I'm going to get, and you might be able to simplify this a little bit. I will point out that 68 is not a perfect square. You can clean it up a little. It does have a 4. But that's about it. It's 4 times 17, and this is 4 times 4. So if you clean it up, you get a 17/4 equals t squared, right? So my t is now plus or minus the square root of 17/4. And I'm going to make the point that here it is worth going ahead and putting into the calculator because you would never answer seconds in something like this. But if you wanted the exact answer, it would be a root 17 all over a 2, right? Because you could take the square root of the 4. Notice that the negative answer is not sensible, right? Because that would be before I drop the raft, right? This model is only good. So they drop a life raft. The moment they drop it is at t equals 0, right? So essentially our domain is that the time has to be greater than or equal to 0 because you can't drop the raft. Like you can't count the time before the raft is dropped. That doesn't count in the problem. And this equation only models the raft when it's in free fall, right? Based on the effects of gravity. So anything before t equals 0, this equation would not be valid. So my answer could either be, if I didn't have a calculator, that my time is the square root of 17 all over a 2 seconds. That's fine. But honestly, most of the time when we're answering a science question like this, we're going to want to go ahead and clean up our answer. So it's going to end up being 2.061 or 0.062. Remember, you can round or truncate, right? So my answer is going to end up being 2.061 or 2 seconds because I can round or truncate, right? Remember, thousands place always, and truncate means cut off, which would be the 1, but if you chose to round, that 5 would round it up to a 2, okay? All right, you're going to try a P3, same idea. The only difference is that now the helicopter is only 34 feet from the raft, or from the ground, rather. So same idea. Hit the ground means h equals 0. So 0 equals negative 16 t squared plus 34. 34 equals 16 t squared, however you want to add it. So 34 over 16, I can cancel a 2 out of both of those. I get 17 over 8 equals my t squared. I know that logically, plus or minus doesn't make sense in this problem, right? So I can put a big old no to the negative, because again, I'm dropping the raft at t equals 0. So the answer is going to be either the square root of 17 over 8, the whole thing, in seconds, not approximately, or the better answer in this case, because when we're talking about science, we usually want the answer in decimals. The better answer in this case would be the square root of 17 over 8. And I get 1.457 or 458, depending on if you round or truncate seconds. So if we drag this here, I either get 1.457 or 8. Oh, my bad. I take it back. There we go. 1.457 or 8 seconds. Again, you're not going to put both, right? So this is where the line is. You either round or truncate, not both, okay? All right. That's the end of this video.